Past papers are an important tool for revision, allowing students to check how their revision is going and assess areas for improvement. Well, in this lesson, we've just sampled a question from 2020, a question in chemistry from last year. That's the one we are going to do. This question is very important to those writing exams in December, but also for those who will be writing exam. Okay, so that's the question. In an experiment to prepare a salt, a learner reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeter of dilute nitric acid of concentration 2.0 mole per decimeter cubic or per cubic decimeter. A. Write a balanced chemical equation for the reaction. B. Calculate the number of moles of Roman numeral 1 magnesium oxide, Roman numeral 2 dilute nitric acid. C. Determine the limiting reactants. Determine the limiting reactants. Okay, so that's okay. So the questions, you can be referring them from here. Okay. So this is our worksheet. This is where we are going to do our work from, in other words. Okay, so now A is saying write a balanced chemical equation for the reaction. The reaction they are talking about here is this one, the reaction of magnesium oxide with dilute nitric acid. So we need to write a balanced chemical equation. Okay, so now magnesium, which is Mg, magnesium oxide, is reacting with nitric acid. This is the formula for nitric acid. So when magnesium oxide reacts with dilute nitric oxide, we are going to have magnesium. We are going to have here nitrogen trioxide plus water. So that's our equation there. Magnesium oxide reacting with nitric acid, which will give us these products. When magnesium oxide reacts with nitric acid, these are the products. Okay, so in chemistry, always you need to balance the equation. If the equation cannot be balanced, meaning the equation does not exist. So in chemistry, always balance the equation. So we need to balance this equation. Okay, so we need to put a 2 here, and where else? Also a 2 here. The equation as balanced. Also, you need to include the state symbols. Of course, this one, magnesium oxide, is in gaseous states. Nitric acid, this one, it's in aqueous state. Same as this one. Okay, aqueous state. Water is in liquid state. Okay, so we have answered this one because it's saying write a balanced chemical equation. This is the equation they are talking about. B, they are saying calculate the number of moles of magnesium oxide. Calculate the number of moles of magnesium oxide. Okay, so you know the formula. Say number of moles is equals to mass divided by relative molecular mass. Okay, so mass they have given us in the equation. What's our mass there? The mass is 3.0 grams, 3.0 grams. That's our mass there, mass of magnesium oxide. Divide by what is our relative molecular mass, the relative molecular mass for magnesium oxide. So magnesium oxide, magnesium has got is on 24, oxygen is 16. When you add this is 0, and there is 4. So our relative molecular mass is 40 grams per mole. Okay, grams per mole. Okay, so now number of moles of magnesium oxide is equal to, when if you have your calculator there, you punch in those numbers and you'll get 0.075, which is more. That's our final answer there. Of course, the grams here, they are cancelled, that's why they are not here. The grams, they were cancelled from there. So 3.0 divided by 40, number of moles is equal to 0.075 mole. Okay, so Roman numeral B is saying dilute nitric acid. Okay, so for nitric acid, the formula is this one. The formula is this one. So number of moles for dilute nitric acid is one here. So number of moles for nitric acid. If we check in this in the experiment there, we've been given, let's just write data here. We've been given the concentration, which is 2.0 mole, 2.0 mole per cubic decimeter, Then we've also been given the volume there. We say 40.0 centimeter. Okay, so we've been given the concentration here as well as the volume here. So we are going to use that formula. You definitely remember this. This is a triangle. Yeah, this triangle. Here there is number of moles. Here there is concentration and volume. So we are going to use this formula to say number of moles is equals to concentration times volume. Since we've been given this, so we're just going to plug in the parameters we've been given. Concentration we have been given, which is 2.0 mole per decimeter cubic, or per cubic decimeter, multiplied by the volume there they have given us, which is 40.0 centimeter, 40.0 cubic centimeter there. Okay, so one thing that you need to know and understand is that when calculating number of moles using this formula, volume should always be in cubic decimeter. Volume must always be in cubic decimeter. So here what we are going to do, we are going to divide by 1000 1000 centimeter cubic per decimeter. Yes, like that. Per cubic decimeter. This is D per cubic decimeter. So cubic centimeter and this cubic centimeter are going to cancel. Okay, and also this decimeter and this is going also to cancel. So when you divide this 40.0 by 1000, you are going to get, we are going to have 2.0 more 0.04. So number of moles of nitric acid, of dilute nitric acid, is equal to 0.08 moles. So that's our final answer, 0.08 moles. That's our final answer. So now on C here they are saying determine the limiting reactant. Determine the limiting reactant. Okay, so now when answering this one, from the moles calculated, this one and this one, from the moles calculated, the one with the small number of moles is the limiting reactant. So the one with the small number of moles is the limiting reactant. So between number of moles of magnesium oxide and also number of moles of dilute nitric acid, the smaller number is the limiting reactant.